All right, so the other day I did a video about the new panic screen inside of the Linux kernel. So I thought, hey, while I'm on the subject, why don't I put together a quick video that shows you how you can get the Linux kernel compiled, and then also how you can get the Rust support enabled, which is necessary for the QR code functionality. So let's look at that today, and let's do that within the confines of enabling the panic screen, and specifically enabling the QR code screen. All right, so I've got a VM set up here that we can use. It's pretty much a brand new environment. I don't have anything installed because I wanted to go through the steps one by one with you. So first up, I need to get access to the Linux source code. And this one I did do in advance just to save some time from pulling it. So if I change into the directory with Linux next here, and if I take a look at the repo here, you can see this is the repo that I cloned. It is the next version that's being developed. It's not actually 6.11, which isn't released yet. It's actually going to be the basis of 6.12, or at least that's my understanding of this particular Git repo. All right, so I've got that source code checked out here. So the first thing I need to do here, I need to get some of the basic tooling installed. Some of it might already be here from a default install. Some of it, though, I need to add. All right, so I've got some packages to install here. Build essential, libin, curses. Basically the foundation of being able to compile the Linux kernel. I can just run that then and install those packages. All right, once those are installed then, the next thing I need to do here, I need to develop a configuration for exactly what I want to compile. So what modules do I want to include? What drivers do I want to include? And one way to start that process, because basically I'm going to create this file, a config file, a .config file. You can see it doesn't exist right now. So one way I can start this out, I can actually take the current kernel that's running on this machine. I can copy its configuration, and I can use that as a starting point. And then the next thing I like to do if I'm just tinkering and playing around with the kernel and I don't want to waste a bunch of time compiling, taking an hour to compile a new kernel, well, then I can do something to trim down the configuration to basically get rid of everything that I don't need. And one way to do that, I can use this call to the make command. And I can call the target local mod config. I don't even need the yes part. I'll get to that in a moment. And then I'm also passing a parameter here for LLVM because I need that for the Rust support. I need the LLVM tooling. So I'm specifying when I compile, don't use GCC, use the LLVM tooling instead, and specifically version 18. And so now if I run this, of course it fails, and that's because in this brand new environment, I don't have Clang installed. I don't have that LLVM tooling. So I need to go grab that. So I'm going to jump down here. Now this will be environment specific. In this case, for my Ubuntu environment, I can run this script here. So I'm going to download a script and then I'll execute it. And this will go through the process of installing LLVM, Clang, etc. All right, once I've done that, I can bring back my make command here and I can run that local mod config target, which will take that initial .config file I had and it'll strip it down to the bare minimum for this machine. So I'll run that now. And as you can see here, I'm actually prompted with a question, which I don't want. I prefer to have this process automated. So I'm going to kill off this with Control C. And then the reason you saw that previous command that I had a yes in the front of it. It's because I basically want to pass a blank line anytime there's a question, which will accept the default answer. So I'm going to run my local mod config and strip down. Anything that's unanswered that needs an answer from me will just be answered with basically use the default. All right, so now when I run this, I'll strip down my config. Looks like that works successfully. All right, so now I have a base configuration. One thing that I think can be nice to do just to see what's going on. At this point in time now, I could go ahead and create a directory to keep track of my configs if I want to see what I'm doing between each set of modifications, because there's some more configuration to do here. So up a directory, I could create a configs directory, basically a backup directory. And then from here, I could copy that .config. And I could copy that up a directory. And maybe I'll call this O1 local mod config. That way I know it's at the very beginning of the process of setting up my config file. Go ahead and copy that. All right, now I need to take that config file and further modify it. I've got a couple of lines here to run that will make changes to it. So in addition to using the make file and the make command, I can also run scripts here that will enable or disable or set values. I'll go ahead and paste these in here. This will set two different options to an empty string. Now, if you want to see what change that had, now that's when I could use something like icdiff here. I could go up a directory here into the configs directory, grab that config right before I made the change, and then I could compare that to .config here. All right, so now when I run this, and I'll zoom out a little bit here, you can see the change that that had. It actually just cleared out one of the options here. And so that means the other option was already empty. Anyways, that configuration is done now. So next up here, actually, by the way, if you wanted to verify the LLVM tooling, aside from using the make command, you actually could run the commands yourself. Paste those in here. You can see those are both working. They give responses back here at the version. And if you note on the end of these commands here, there's a -18. That's why I had to pass the -18 to the LLVM option when calling make here. So that -18 basically looks for whatever tool like Clang here, and then it's going to be Clang-18 for version 18. So that's where that comes from. All right. Next up, we want to take a look at, do we have Rust support available if we want to add that to the kernel? In other words, does our machine support the ability to build Rust code? So I'll copy this call here. This is a different target. So make and then Rust available. If I run that, it's not going to work because I don't have the Rust tooling set up. And it actually gives me a reason why it failed. I'm missing the Rust compiler. So I know what I need to add to my system. All right, so I'll clear that out here. And I'm going to copy and paste this call here to install Rust up, which is a tool to help you install Rust tooling. And I'm going to proceed with a standard installation, which that's just return here. You can see it's downloading the Rust C component there. That's what we needed for our make Rust available command. That's what was missing. All right, once that's done then, a couple things I could do here. I could see if I have the Rust up command. Looks like I don't have it. Now I could go ahead and manually activate the environment, or I could just exit out of my SSH session, open up a new shell again, and now I should be able to see Rust up here. Could grab the version on that. And of course, I want to make sure I have Rust C. That's what the Rust available target was looking for. And I've got that. So if I run my make command again, check again if Rust is available. Oh, if I change into the right directory, actually. All right, you can see now I'm missing the Rust bindings. So step by step, this can help me go through the process of setting up my Rust tooling. And if you're curious, the Rust up command has a show subcommand. This will show you what's installed right now. You can see I have a stable release of Rust 1.81. Of course, I could use the Rust up tooling to install a different version or specify to use a different version, but right now this is sufficient. So we'll just move on to those bindings. So to install those bindings, I can use the cargo install command to install those bindings, and I can start out by just listing what I have installed. I've got nothing right now. I want to install a package called bindgen-cli. Give that a second. Okay, once that's done, I could confirm it by listing out the packages again. There it is. So now that I have that, I can run my make command again. I can run the Rust available target again, cross my fingers. And oh, so close. We've got one more thing we need, though. We need source code for the core standard library. All right. For that, I can use Rust up to grab a component called Rust source. Once I've done that, now if I run my Rust available target, you can see Rust is now available. All right, so now that we have Rust, we can go about the process of setting up our config file to enable Rust support in the kernel, as well as to turn on some of those features for the panic screen. And so there are two ways I could do this. One way that you might want to go about doing this when you're first starting out is to use menu config. This is a target that will load up a menu. You can see all the different dials or toggles that you have. You can go through menus here. For example, I could come up to general setup, go down to the bottom here. There should be Rust support here, except it looks like something's missing. So another thing you can do inside of menu config, you can search for things like Rust. You can search for Rust, and you can see right at the top the symbol for Rust. It's set to disabled right now. That's what the equal sign and the N means. And if I want to know what I need to be able to enable this, in other words, to show the button to turn it on, you can see there's a depends on line here. If you go through the elements here, do I have Rust? Yes. Rust is available. Yes. Need to make sure this one is turned off, and it's turned off with the no here. This one, mod versions. This should be turned off. It has a bang on the front, but it's not, so it has an equal Y. So I need to disable mod versions. And then if I keep scrolling over here, way over to the right, there's one more option I need to turn off. It's this shadow call stack right here. You can see it's set to yes right now. And then the rest of those are turned off already. So we just have two changes to make. Now, I could go about the process of finding those inside of this menu config, or I'm just going to exit out of this, escape a bunch of times, and not save the configuration, because I prefer to use a script like I did just a moment ago with those keys that I erased. And I've got this saved down here just so I can copy and paste and save some time. All right, so I need to disable mod versions and shadow call stack. When I do that and paste that in, all right, so now I could run the make menu config again so I can show you that Rust is now a checkbox. So if I come down to general setup, come down to the bottom here, There you go, way down at the bottom. I can now hit the spacebar to select Rust support. All right, and then down at the bottom here, I could go ahead and save, overwrite my file, and then I could just exit out by escape a bunch of times. All right, so next up here, oh, and by the way, you could use scripts config here to enable Rust support as well. That's another route to go. I just thought it might be helpful to see the menuing system, which that menuing system is incredibly helpful when you have a dependency that you're missing to see what it is. All right, so next up, I want to turn on some of the panic screen features. Now, again, I could do this from the command line here. How about we open up that menu config again, though, and I can show you where that's at. I come down to device drivers here, hit page down and come down to graphics support. Come under the DRM section here, Direct Rendering Manager. All right, so a couple of options down here is to display a user-friendly message when a kernel panic occurs. Go ahead and hit the spacebar for that. That pops up two more options here. We can leave the defaults if we want to, or we could change the color. Maybe in this case, I want to come under the background color here, hit return. I can set a value then. Maybe I want this to be red, so I can put FF on the front for red. Green and blue will be zeroed out, so that'll be a nice, bold red color. And then there's also an option down here that I'm going to turn on, which is a debug feature that makes it easy to test the new panic screen without triggering a panic. So I'll go ahead and hit space there. And then if you can see a couple options down, because I have the Rust support turned on already, I now have an option here to add the QR code. So I can hit a space here. And if I want to, I could actually come up to the panic screen formatter, and I could change this to default to the QR code. However, I'll just leave it with user right now, and I'll show you how to change the QR code in a minute. And then the only last thing I might want to do here is to come under and specify the URL of the website that can decode the barcode and show what exactly is inside the compressed data inside of the barcode. I'm actually going to leave this blank though, and instead I'm going to exit out here, escape a bunch of times. I'm going to say yes to save the configuration. And then before I make that last change there, this is why it's nice to have the IC diff here. I can diff over that initial config to the current config. You're going to see all the changes are made. Quite a few things in here are changed, so that's not so helpful. If, however, I go ahead and make a copy of the config file, maybe I'll call this one O2 DRM panic. That way I know it's right about the end of configuring the panic screen. I copy that. Now, that base URL I just mentioned a minute ago, I want to show you how you can use a script call here. You can use a script call here to set that base URL. So I could have done it inside of menu config. I just want to show you that everything I did in menu config can be done outside of menu config. Paste this in here. And now if I run an IC diff on the O2 config versus my current config, you can see there's a single change that was made to set the base URL. So just know you can use this config script, or you can go into menu config, either works. I tend to prefer the config scripts just because it's easier to reproduce the environment. But if you're starting out and you're learning about some of the configuration options, it can be helpful to have that nice graphical interface to jump around and see what you're missing. All right, so after a ton of config options, I could just jump right into compile. Sometimes I like to verify that I didn't miss anything, especially if I'm doing things manually in the menu config. So I can start out with a grep here, look for DRM_panic, which is part of the key or the name of the options for the panic screen. Look inside of the config file for that. Now I can just go through and confirm, yep, I've got the panic screen turned on. I've got the debug mode turned on as well. Also got the QR codes enabled if I want to use them, though I'm defaulting to just the text message or the user message. And I've got my red background, as well as my base URL. So that's a good way just to check and make sure I didn't miss something. And I could do the same thing here if I want to look at Rust support, config_Rust. You can see config_Rust is turned on. That's great. It's available. That was cached as a computation that it is available. And it has some information about the particular Rust environment. All right, so now maybe I want to make a final backup here. We'll call this one O3 Rust QR. And now I'll go ahead and grab this command here because I want to run make to compile the kernel. However, I also want to grab some timing info, so I put time on the front. All right, so just like previously, I am passing LLVM equals -18, and I'm specifying to use the number of processors I have available, all of them. So go ahead and run this, cross my fingers I didn't forget something, and we'll see what happens here. By the way, I'm just going to cut out the time here of this scrolling. By the way, if you get any warnings, that's not a huge problem. If, however, you see some errors along the way, at that point in time, Control-C to kill off the process, address the errors, and then resume the compile later on. Just be aware you can easily scroll past those errors, though. Keep compiling other things that are unrelated. And then at the end of it all, you'll see that there is a compilation error and you have to go back and fix that. Either way is fine. Whatever it does get to compile successfully, you can just continue to reuse with an incremental build. I, however, think it's good to figure out those errors soon enough so you can work on those while the rest of this is compiling. All right, once that's done, the fan should spin down. Even on my M1 Mac here, the fans were roaring away there. Looks like it took about 5 minutes, 5.5 minutes here on my machine. Actually, no, it looks like it took 6 minutes here. Not terrible, actually. This is a VM running on my M1 Mac. And given I stripped down that configuration using the local hardware as a reference and the current modules that are running, that's why I got such a fast build time of only 5 minutes. And now, of course, if I make any more changes, I can just recompile the changed components. It shouldn't take very much time at all to perform a new kernel build. But before we do that, let's talk about the process of using the kernel that we just set up. So now, the next step here, I'm going to go ahead and install the modules. Don't really need the timing information. This is quick, so I'll just do this sudo here, make, and then the target is modules install. Run that. Maybe a second. After that's done, go ahead and do a sudo make and the install target this time. This will install the kernel. Now, before I do that, though, list out files here n/boot. You can see right now I only have a 6.8 kernel in here. All right, so now go ahead and do the sudo make install. Maybe take 3 or 4 seconds. Yes, there's a problem here. Now, this is specific to my environment. You're likely not going to encounter this. However, I'm using a Parallels VM, and it has some parallel tooling installed inside of it, and there's a problem recompiling the module for that. And so what I'm going to do just to work around this, I'm basically going to remove this so I won't have the parallel tools. You can see if I run a DKMS here for the module, get the status, there's the version that's installed. I can go ahead and get rid of that then. Give that a second. Grab the status again, it's cleared out. Good deal. All right, now that I've done that, I could go ahead and run the make install again. I think that'll be fine. I just want to look at the boot directory again and make sure nothing's copied in there. Yes, a couple of things have been copied in here. So in my case, I'm just going to get rid of anything that was added. I'm building the 6.11 kernel. It's actually 6.12, I believe, but it's called 6.11 here. Anyways, I'm going to remove any references to 6.11.0 inside of the boot directory. And then, all right, you can see I'm back to the starting point. Now I can run the make install again. Cross my fingers, that should be fine. Should take about 3 or 4 seconds. All right, that's done now. If I list out the /boot directory, you can see there is the new kernel. I cleared it out. I should have showed you at first. Maybe I'll run the make install again. It won't hurt anything to do that. What I wanted to show you, because I cleared this off too soon previously, you can see the grub configuration is also being updated here. It's detecting various kernels, and then it's adding them to the grub config so we can boot off of them. Now, because I ran that make install again, you can see there's a .old version here. I just want to get rid of all those again here. So I'm just going to clear out all the 6.11 kernels again, run make install one time. That way I only have one 6.11 kernel. So every time you run make install, you're going to be installing a new kernel, and the old one will just have .old appended on the end of it, and you'll get a bunch of them, and you might even run out of disk space inside of this boot directory. So I like to just wipe them out so I don't have to keep track of which version does what. I just like to have one version available. All right, now just looking at the order of kernels here, you can see it reported 6.11 was found first. So in my case, I'm actually free to just reboot right now, so I'll go ahead and do that. Reboot the machine here. And just wait a second. I can look at Parallels if I want to see this. You can see it's booting up already, and it should be booting off the 6.11 kernel that I just compiled. All right, that's up and running. I love how fast that is. Don't know how it's so incredibly fast, but it only takes about 5 seconds for a reboot with this M1 Mac. It's lovely. All right, so I need to get back into the VM here, and I'll just verify the kernel that's loaded, uname-a. There you go. You can see it is the 6.11 kernel, whereas previously, if I look in /boot, you can see it had 6.8 to begin with. So it's got my new kernel. That's good news. And I'm actually able to SSH in and run a shell, and everything looks okay. Let's go ahead and test that panic screen next. All right, so to see this, in the case of Parallels, I've got the GUI pulled up right here. I'll split the screen here. And then I'm going to cheat by copying this command over here. And I don't think this is actually going to work because there's one change I need to make to the grub config. When I run this, though, you can see it fails. The file doesn't exist. And that's because right now, if I go ahead and run dmessage, I grab my kernel messages, and I grep for DRM. In terms of modules, initially my display, this display right here basically, this display was initialized with a driver called Simple DRM, which is compatible with the panic screen. However, later on, you can see it was initialized with a different driver. In this case, this is not compatible with the panic screen, not yet. So I need to do something to tell the machine not to use this particular driver. So what I'm going to do is I'm going to blacklist this. And I've got a command here just to copy and paste and do this. Essentially inside of the default grub configuration, there's an option here to specify arguments to the kernel, and nothing is set right now. So I've got a command here that when I run this, it'll actually set that, and it'll add to the list of arguments modprobe.blacklist, and then it'll specify that vert.io GPU. That way that won't be used, and instead it'll have to revert to just using that simple DRM driver, which is the one I want it to use. When I run that now, if I look at the default grub config again, you can see it's now set on this line here. So that's good to go. And so now that I changed the grub config, I need to update the grub configuration that's actually used in the boot directory. So I'll do that. Okay, once that's done then, go ahead and reboot. Come over here. Just wait for this to start back up. I'll split the screen here. Once that's up and running, SSH back in, cross my fingers. Could go ahead and look at the kernel messages again. All right, this time you can see it was only initialized with simple DRM. So that looks promising. And if I just type echo here, grab my command from before, cross my fingers, look at that, we've got a panic screen. There's our red background with white text. And of course, this is just a test panic screen from how I triggered this. You can watch my video from the other day if you want to know more about that. So the only other thing I want to do here, because the QR code requires the Rust support, let's go ahead and take a look at the QR code. So if I change the panic screen type to the QR code, of course, it's not going to already change it because this is a previous panic screen. I need to trigger the panic screen again. There you go. There's a barcode. So now I could scan that barcode, go off to the website, decode the barcode, and look at the messages. Right, so that's about it in terms of compiling a new kernel. I know I went through a lot of configuration just to be able to turn on some of the knobs here to do something interesting. Please don't be intimidated by the amount of configuration. I really didn't have to do most of that. If I just wanted to compile a kernel with Rust support, I could have done a lot less to get that set up. That's the bulk of what you want to do, is just deciding what you want to be compiled into the kernel. And then it's pretty easy to get a new kernel up and running. Before I leave, though, I do want to show you there are some things that might go wrong in terms of the order of the kernels detected by the grub bootloader. And so you might want to set some options here to be able to see the bootloader screen. So right now, if I reboot the machine, you don't see the bootloader. If I increase the amount of time it waits to 5 seconds here, it's 0 right now, I believe. Let's dump that out here. You can see right now, the timeout is set to 0 seconds, so it never shows the screen. The timeout style is also set to hidden, so it wouldn't show it even if there was a timeout set here. And then the other option here is the grub default. This specifies which menu entry you want to use by default, and it's set to 0 by default. So I'm going to change all 3 of those. Paste in the code here. By the way, all of the code I'm using here, it's out in a repo that I'll link down in the description of this video, so you can go grab that and use it. All right, so once I've run that and I dump out the top of that grub config again, you can see now the timeout set to 5 seconds. Timeout style is a menu, so I'll actually see it. And then for the option that we use by default, instead of 0, it's now 1, and then a little arrow, if you will, and a 0, which means take the second menu item, it's 0 based, go into the submenu, and take the first item. You'll see this in a moment when I go ahead and reboot. Before I do that, though, I updated the grub configuration, so I need to run the update grub. Otherwise, it won't actually apply that. All right, so now let's go ahead and reboot here. Split the screen. I want you to see this here in parallels. It'll start pretty quickly. Over on the right here, you can see there is the bootloader. And if I want, I could intervene. It's got an asterisk next to this menu entry, which is the second item, which would be 1, which is what I put over here in the grub default. Right, so now if I hit return to open up the submenu here, you can see there's 4 different options. And I had 0 set, which would be the first item. If you wanted maybe this one instead or this one instead, you could do 1 or 2. So you can just reboot and take a look at the grub bootloader if you want to find the order of things to decide how to set the grub default. Or once you've booted up, you can actually dump out the contents of the grub configuration file. You can find menu entries and you can go about figuring out which one you want that way, so you don't have to reboot and look at the actual bootloader. All right, once that's up and running, I'll show you that now. Hop back in. And in this case, if I grep for menu entries inside of, and then it'll be /boot grub and grub config. So if I grep for menu entry inside of there, oops, you get a snapshot of the various lines that match here. Here is the advanced menu. You can see it is the second option right after the initial Ubuntu option. Inside of the advanced menu, you can see this is nested here. Here's a menu entry. This is 611. That's the one we used. There's also a recovery mode, which turns off some of the options that might be causing problems. Then there's 6.8. And then again, for 6.8, there's a recovery mode as well, kind of like a safe mode in Windows. So you can see in this case, if I wanted to boot 6.8 by default, that would be the third menu entry here underneath the advanced menu. In that case, then I would pick 1 for the advanced menu, and then I would pick 2 for the third entry within the advanced menu. So then I would update my grub configuration. I'll show you that one more time here. So I want to update that option right here and make sure you put quotes around it. All right, so I think that's it for now. Again, I have a repo with this code in it. You're welcome to copy and paste from it. Lots of little notes and extra little tangents. Take a look at that. And then let me know in the comments down below, is this something that you find helpful? Would you like more coverage of the Linux kernel? If so, what specific features? Let me know down below.